Hello everyone. Now after discussing preparation of amines, now we'll further discuss the physical properties and then we'll discuss the chemical properties. So first I am taking up some of the very important physical properties of amines. Among the physical property we first have physical state, color and order. Now remember, in exams you need not to remember, they are not directly asked like what is the physical state of amines, what is their smell, like that. Now, but when you remember all these things, then they will be helpful when they ask some questions like in which organic compound has to be predicted. In that they write there is an organic compound which have a fishy odor. So once they have written fishy odor, immediately it should be in the mind that they will be amines. Fine? Okay. Now the lower aliphatic amines, just like methenamine and ethenamine, they are gases and they smell like ammonia. Lower members are gases because intermolecular forces are weak in them. Then primary amines having 3 or more than 3 carbons, they are liquid also, because as we know, as the chain increases, intermolecular forces will increase and from gases they turn to liquid. So all these liquids have fishy odor. So this is a specific thing about them. They are of fishy odor. Fine. Then among the lower aromatic amines are liquid with unpleasant smell. Just like aniline is one of the lower aromatic amine. Then among the higher members, intermolecular force increases, but not that much. They are solids but having low melting point, right? And they are almost odorless. They don't have any specific smell. Moreover, aromatic amines are toxic also. Just take care of this. Then regarding color, if the amines are pure, then they are colorless, but they used to develop color as a result of oxidation if they are kept as such. So this is specifically a case of aromatic amines. Particularly aromatic amines, their oxidized products develop some color to them. Fine. Now next physical property we'll discuss, which is very important, usually asked in the exam, is the boiling point. Now we'll discuss regarding the boiling point of amines. Now first of all, amines, if I consider primary, secondary and tertiary amines, then primary, secondary and tertiary amines, all of them are more polar than hydrocarbons due to presence of highly electronegative nitrogen in the compound. Fine. So all of them will have higher boiling point than the hydrocarbons, but remember, of comparable molecular masses. Now see, whenever one property is to be compared, some other factors has to remain constant. For example, boiling point also depends upon intermolecular forces as well as the molecular mass or the size of the molecule. Fine. Now though I have written here hydrocarbons have less boiling point than amines, but I have to say here of comparable molecular masses. Otherwise, if you say methenamine is a very small primary amine, and if you compare methenamine with the boiling point of octane, then there may be difference. Though it is hydrocarbon and this is amine, but it will have lower boiling point, right? Because this octane will have a higher van der Waals forces, right? So whenever we compare boiling point, we keep the molecular mass constant. Fine. So they are more polar than hydrocarbons, so their boiling point will be more as compared to hydrocarbon. Now let's see comparison among primary, secondary and tertiary, right? Now in amines we have NH bonds, though we not have NH bonds in tertiary. Due to presence of NH bond, they develop hydrogen bonding among their molecules. So we see in primary, generally represented by RNH2, R2NH and R3N. Fine. So you see presence of two nitrogen-hydrogen bonds, presence of one NH bond, and there is no NH bond. So there will be very higher extent of H bonding in case of primary amines, less in this, and no H bonding in this case. Fine. So you just see that in this case their boiling points are more just due to their polarity. Fine. Their intermolecular forces are stronger as compared to hydrocarbons, but not stronger than secondary or primary. So among these three, the order of boiling point will be like this, but remember all these three should be of comparable molecular masses. For example, I just tell you, if I take this primary amine, right, this is butanamine, this is primary, fine, and if I take this is secondary, and among tertiary of this kind we will have this. Fine. All these three, this is tertiary, they are isomers of each other, and if we calculate their molecular mass is same, that is 73 AMU. Fine. Then what has been found, I'll give you experimental data. The boiling point of primary is 350.8 Kelvin. Boiling point of this secondary diethylamine is 329.3, and boiling point of this tertiary is 310.5. Right? So this is their molecular mass, which is same because all of them are isomers. Right? Their molecular masses are same, but you know, two NH bonds, one NH bond and no NH bond. Because of that, boiling point is high, primary, secondary and tertiary amines, right? So this was comparison of boiling point among primary, secondary and tertiary amines. I hope it is clear to you. Now, let's compare amines with the other families. We have done that they have higher boiling point than hydrocarbons. Now let's compare them with the carboxylic acids, alcohols, which is very important question, amines. Fine. Now in carboxylic acids we know their boiling points are quite high. They have OH bond, one oxygen is here for another extent of hydrogen bonding. Fine. One extent of hydrogen bonding from here and here, right? And moreover we know carboxylic acids, they form dimer even in the gaseous phase, which shows high tendency of hydrogen bonding among their molecules. Fine. Alcohols have only one OH bond through which hydrogen bonding takes place. And amines, suppose I compare primary amines. Fine. Then normally we just say here that there is presence of two NH bonds, so the intermolecular H bonding extent will be more in the case of amines, right? But we know NH bond, which is a polar bond, OH bond is also a polar bond, but as you know, the electronegativity of oxygen is 3.5, electronegativity of oxygen, nitrogen is 3. So there is larger electronegativity difference here as compared to this, right? So OH bond is more polar as compared to NH bond. So though primary amines are having more than one NH bonds, more extent of H bonding due to this more bonding, but H bonding is weaker because they are less polar as compared to OH bond. Fine. So therefore alcohols have higher boiling point as compared to amines, and we have already done this. Carboxylic acid have higher boiling points than alcohol, but all of the same molecular mass. I have one data here, that is comparison of C2NH, C2H5NH2, ethylamine, ethyl alcohol of just comparable molecular mass, and one comparable molecular mass is formic acid, methanoic acid, and their boiling points I am just giving you. This is 292 Kelvin, then For alcohol it is 351 Kelvin, and for formic acid it is 374 Kelvin. So you can see they are of comparable molecular masses. This is 45 AMU, 40